During this time of year in Norway, residents are treated to a brilliant display of northern lights. Situated above the Arctic Circle, people witnessed a new and just as spectacular show of lights against the dark backdrop. The polar stratospheric clouds were recently captured in the early morning hours by a photographer. The clouds are composed of ice crystals appearing in temperatures of -121 Fahrenheit above the Earth's atmosphere. The crystals give off the bright iridescent colours because it's high enough to catch the sun's rays. Some natural phenomena are rare and beautiful, like red diamonds, the northern lights and double rainbows, but others like nacreous clouds are rare, beautiful and destructive. These clouds develop in high latitudes 60 to 90 degrees of the northern and southern hemispheres. In addition to forming at high altitudes, they exist only at high altitude. These clouds form at 70,000 feet or above, more than twice as high as commercial airliners fly. This is also where the ozone layer resides. Clouds generally don't form in the stratosphere. Typically it's far too dry there for ice crystals or supercooled water droplets to develop. But these clouds are different. They're a mixture of supercooled water, ice crystals and nitric acid. During winter, when there's little sunlight in the polar regions, the stratospheric polar vortex strengthens and locks out warmer air. This creates extraordinarily cold temperatures in the stratosphere. At this point, water vapour changes to a supercooled liquid or ice crystals. Vast quantities of chemical compounds like hydrochloric acid and chlorine nitrate are the result of the breakdown of chlorofluorocarbons, better known as CFCs. How did these chemicals get into the stratosphere? In one word, humans. These clouds provide an ideal surface for chemical reactions that involve CFC-derived compounds. As these compounds interact with these clouds, chlorine gas is released. As soon as sunlight comes into contact with a chemical compound, the molecule absorbs energy and enters an unstable state, initiating a photochemical reaction. In the case of chlorine gas, a bond between two chlorine atoms, photochemical processes lead to the release of elemental chlorine. This is where the atmosphere is affected. Chlorine gas kills the naturally occurring ozone in the stratosphere. One chlorine atom can destroy thousands of ozone molecules due to the catalytic nature of the reaction. This means that chlorine acts as an agent to accelerate the breakdown of the ozone. While the hole in the ozone layer is still prevalent at certain times of the year, due to the reduction of CFC output in the 1980s and early 1990s, stratospheric ozone concentrations have been on the rise. Be that as it may, researchers at Columbia University say that CFCs last a long time in the atmosphere, up to 100 years. So while they may be beautiful, these clouds will be harming the ozone layer well into the future. Thanks for watching, and don't forget to subscribe for more countdown videos.